In this video, we're going to talk about the vertical shift, and vertical is up and down. So let's just put arrows up and down on the side where it says vertical. In the last video, we looked at horizontal shift, which was left and right. So let's just look at the differences between a horizontal and the vertical shift. So notice with the horizontal shift, we have a parenthesis that's grouping our H with our K. So that H is an X. It's a special X, and they go together. But notice here in our vertical shift, we do not have any parentheses with that X. The X is all alone and it's being squared. We have the plus K at the end. So when we look at our vertex form, we're talking about this number that's being added on at the end. So let's go ahead and let's look at our vertical shift. So first of all we're looking at here is our K. So I'm going to go ahead and highlight that. That number at the end is what's making our shift. So let's look inside. And you see the inside looks very similar to what we've done before. And once again, if any of the words got cut off here due to the margin being so narrow, please make sure you write in transformation f at x, where f at x, vertex, transformation. And that continues all the way down. That's very important, especially the f at x, that you make sure you write that in. So let's go ahead and let's color code this the way we color coded this before. So when we look up here, that's our general vertex form. I'm coloring my A in orange and my H in yellow, and my K is in pink. So that means we have to take those values for A, H, and K, and we have to plug them in to the formula. So A is 1, H is 0, and K is 3. So remember, we can get our vertex from those numbers right there. But let me clean it up first because you won't always see it like this. So x minus 0 is just x. So that's just x squared. Remember, multiplying by 1 doesn't change its value. But now we have this plus 3 at the end. So when I'm looking at this form right here, x squared plus 3, I notice that this here is my k because it has a plus something at the end after that x squared. So that there is my k. And I notice nothing is being added or subtracted to this x that is being squared. So that means my vertex is 0, which is what this is right here. This is H and this is K. So that's my vertex. So when I'm looking at my vertex, I see that my x didn't move and my y went from 0 to 3. So that must be an up 3. So let's go ahead and go over to the graphing section. So what we're going to do here is let's graph our parent function. So by now you should recognize that the parent function of a quadratic has 0, 0 as its vertex. Then it's up 1, right 1. Then it's up 3, 1, 2, 3, right 3. Right 1. That's the same as 2 squared is 4. Then I'm going to jump up 5, 1, 2, 3, 4, 5, and over 1. So it's kind of the pattern for your parent. So because 3 squared is 9. So what did I do? I started at 0, 0. I went up 1, then right 1. Then I went up 3, then right 1. Then I went up 5 and right 1. And remember, because we have symmetry in our parabola, since this went over 1 from the y-axis, I can go in the opposite direction 1 over. There's a space of 2. I can go a space of 2. Here there's 1, 2, 3 to the right. I can go 1, 2, 3 to the left. And then I'm going to go ahead and I'm going to dash in the parent function. So remember, we're always comparing to the parent. So this time I'm going to do things a little differently because it's kind of easier. I know that my function went up 3. So that means I can simply go from my parent and I can go up 3. So I'm going to do this in a different color pen. So I'm going to go from my vertex, I'm going to go up 3. 1, 2, 3. So that's my new vertex. Every other point went up 3. 1, 2, 3. 1, 2, 3. I'm going to go from this parent point. 1, 2, 3. This parent point. 1, 2, 3. This parent point, well, I can't go up 1, 2, 3 on that because it's too high. So this is my new function. So all it did was it shifted up 3. So let's go ahead and complete this. We should be able to do the parent directly from memory. In the transformation, it's kind of a little easier because we're only adding 3 onto this value. But you could go ahead and do it in the Desmos calculator if you choose to do so. So if I square this, it's -3 times -3 is 9. -2 is 4. -1 is 1. 0. 1 times 1 is 1. 2 times 2 is 4. And 3 times 3 is 9. And we could check those points, and we could see that these black dots are exactly -3, 9, -2, 4, and so on. So now, for the transformation, remember that this was x squared plus 3. This is x squared, so I can add 3 onto that. I get 12. If I add 3 onto this, I get 7. If I add 3 onto 1, I get 4. 0 plus 3 is 3. 1 plus 3 is 4. 4 plus 3 is 7. And 9 plus 3 is 12. Okay? When you have just a vertical shift, it makes it easy just to go ahead and do that straight out. So let's go ahead and check to see if we in fact put these points in the right place by comparing it to our table. So -3, well, that's off the chart. Where's -3? -3, remember I said that was too high up, so we didn't graph it. So at -2, we got 7. At -1, we got 4. At 0, we had 3. At 1, we had 4. At 2, we had, my eyeball's off. At 2, we had 7. And then again at 3, it was off, so we didn't graph it. So what I just showed you is how you can just do the transformation based on the parent function and skip the table altogether. However, I still want you to check using your table of values to make sure you've done this correctly. So there's one more thing that I want to do with this vertical transformation. And you can do this with any graph. Oh, actually, before we do that, let me back up. Let's go ahead and let's label the vertex, and let's label the axis of symmetry. So our vertex now is here. So I'm going to label that. I'm just going to label that in green as my vertex. So this here is my vertex of the new function, which is at 0, 3. And because it's at the bottom of the parabola, it is a minimum. So if you remember from the previous videos, we talked about this vertex down here is a minimum, and when it's at the top, it's a maximum. So since it's at the bottom of our parabola, it is a minimum. Then the next thing that we're going to do is we're going to put in our axis of symmetry. So in this case, when I fold that parabola in half, my axis of symmetry is the same thing as my y-axis, which is, I'm going to put AOS, which is where x equals 0. So that's my axis of symmetry. This is my minimum at 0, 3. Okay, so on to something that we've not talked about, or it's been a while since we've talked about it. And that has to do with increasing and decreasing. So we're going to talk about increasing and decreasing intervals. Okay, so with increasing, we're going to color our increasing in purple. I'm just going to underline that because it's so dark. And then for decreasing, and if you don't have these colors, just do 2 separate colors. I'm going to color that one in blue. I know they're close. So the thing that you need to think about with your increasing and decreasing is you want to know what values of x make y either smaller or larger. Okay, and I'm going to explain what that is. So let's go ahead and we just draw one parabola. I'm going to draw a parabola going up, just like we've been doing. And notice I'm not putting it on my XY axis right now. So the first thing I'm going to do is I'm going to look for my vertex, which is right here. So this is my vertex. I'm just going to label this HK, and we'll look at a more specific example another time. So this is HK. So remember that HK is the same as a special X, Y. And remember that when we're looking for increasing and decreasing, we are only concerned about this value right here, my X value or my H. So if I'm thinking about slope, I'm going to take my ruler and I'm going to look from the end to that point there, my vertex, and I'm going to draw a line. I have some new pens that are needing to be started. So I'm just going to draw, and you can draw this in very lightly. So we see this line right here, and this here is decreasing because the slope is negative. So this line here has a negative slope. So since that section from the very tip to my vertex, if I draw a line, is negative, that means that this part of my parabola is decreasing. So if I'm looking at my x-axis, remember I don't care where that parabola is according to my x-axis, right here is that h value, whatever that vertex x value is, which means every number on that side makes my y smaller, going from left to right. So this here is negative infinity all the way to whatever that vertex value is. So the interval, this would be an interval of decrease. And my interval of decrease would be from negative infinity all the way to h. Okay, so this here is not a point. You can think of it kind of as domain, but it's not a point. Okay, so that parabola had something else on the other side, right? So instead of writing it on here, which I could, I'm just going to pretend it's the same parabola. It's not going to look the same, but let's just pretend it's the same parabola. So I'm going to draw that here. I'm going to put my vertex. And then remember, I want to look at this side. So when I look at this side, I'm going to draw my ruler from that arrow through the vertex, and I'm looking at that, and I'm thinking, wow, that is a positive slope. Okay, that line there is a positive slope. So that means that this section here, oh, I just realized I colored it wrong on the top. I switched my colors. We'll go ahead and correct that in a minute. So this here is increasing. So I'm going to go ahead and I'm going to look at this with just the x-axis. So when you're looking at this on a regular graph, you'll have both the x and the y-axis. So you'll have to train yourself just to look at the x-axis. Right here is my HK, which is a special XY. So I see that all numbers to the right draw my function up. So way out here is positive infinity. So now on this one, I have an interval of increase, and that's going from whatever this value of h is all the way, every single number, up to positive infinity. And remember, this is not a point. Okay? So let's go ahead and I'm going to highlight the h value here because that's what's important. So let's go ahead and correct this mistake up here. I did my decreasing in purple. So I'm going to highlight that all in purple because I'm just going to make a mistake. And my increasing was blue. So I'm going to highlight that in blue. Okay? So we can also put some of these things in words that might be helpful. So this here is all x values left of all x values left of the h, and this here is all x values right of the h. So let's write that down here. All x values right of h. So that was a lot of information that I gave you about intervals, as well as completing your transformation. So what I would like for you to do is I would like for you to try to do the transformation when we have it looking like this. Oh, by the way, when we had this plus k, let's do this. That plus means up, and I'll help you out on this one. Right here, this minus, if we have a negative number, means down. Okay, I'll see you later.